Turbo API is an NPM library that makes building an API quick and easy. It's essentially a fancy wrapper for Express.js. Think Entity Framework for .NET, but for JavaScript. I wanted to be able to create APIs easily without having to deal with the minutia of data validation, permissions, writing redundant CRUD methods for several tables, etc. So I built a generic API framework that handles all of these things automatically with a few settings. It can even handle multiple backend services, so you can migrate your entire API from, say, Firebase to AWS, or AWS to Azure, without having to refactor anything. Just change some configuration options. To get started, create an app in Google Firebase. You can use any existing Google account to do this for free. You'll have to set up an account with a payment method for this to work, but you can do a lot for free or cheap, and you can set a budget for your account as well. In the menu on the left, click on Build and then Functions. Click on Get Started to see the setup instructions. There won't be anything here until you deploy. You can get your Firebase credentials from the project settings here if you want to build a front-end application like a website or a mobile app that can talk to your Firebase app. This is also where you can set up registration and login methods for user authentication. Next, install Firebase tools if you don't have it already. Next, create a folder for your Firebase project. Log into Firebase through the console like so. And initialize functions like so. You can even use an existing functions app if you have one already. You can also decide here whether to use TypeScript or vanilla JavaScript, or whether or not to use linters, etc. You'll also need to run npm install, but Firebase Tools also does that for you as part of this process. In your Functions app, you should have an index.js or TS if you're using TypeScript. This is where you'll set up your app. Next, you need a config file called turbo-config.json inside your Functions folder. This is where you can specify your backend services and define your controller routes. If you want to customize your data services, you can extend the existing Firestore data service to add methods. Simply add the files wherever you like, import it into your index file, and register it with the service factory, like so. Your data service will now be available to use via your config file, using whatever name you want to give your custom service. Turbo API uses a routing controller system to define the endpoints. Each controller defines a route, and you can place as many endpoints on that route as you need. For simplicity, basic CRUD methods can be set up like so. These come with some optional configuration options that allow you to customize these actions, like making them all admin-only, allowing public access to get endpoints, allowing users to delete their own content, etc. By default, these methods come with some metadata, namely created, a date, created by, a string for a user ID, modified, also a date, and modified by, also a string for a user ID. These behave as expected, denoting the creation time and user, as well as the most recent modification time and user. These can be excluded with the no metadata option. However, with metadata included, this gives you the option of using the built-in getMy and getRecent actions as well. These come by default with the use of the full CRUD method, which adds these methods to basic CRUD, along with soft delete and undelete methods, which set the isActive property. You can also add granular endpoints in addition to or in place of basic or full CRUD methods. These can make use of the built-in data, logging, and auth services as necessary. Look at the controller base class in the Turbo API source code to see how the CRUD methods work. To create a controller, extend the controller base class and set up your endpoints in the configure routes method. You can import a number of tools to help make this process easier, including validation, data services, HTTP helpers, etc. To set up validation for your data models, which can work with either SQL or NoSQL data services, you can define models by setting up properties and rules. These determine what properties will not be excluded and what limitations apply to them, respectively. Incoming request bodies are trimmed following the set of allowed parameters, then defaults are added, if any exist, and then the remaining properties are validated according to the rules. You can define the rules that determine the shape of your data table models or request body models by creating rule objects. The properties of these objects define the specific rules you want to apply to your model properties. For instance, in a database of books, you would probably have a books collection with a title property. If books are required to have a title that is a certain length, you can specify that here. You could also use the reference rule to determine a foreign key relationship to another table, like authors. You can also use the rule functions to simplify this process a little by passing your rule properties as parameters to the rule functions, like so. Validation rules include minimum and maximum lengths for strings and arrays, min and max values for numbers, type restriction, foreign key relationships, even for NoSQL setups, enumerables, and conditional requirements. For instance, you can set a property to be required if and only if another property has a specific value. Like in a database of dictionary terms, you can restrict a set of definitions to only have a tense property if the part of speech property is equal to verb. Properties can also be required, unique, or come in unique combinations. This can be useful for certain joining tables. You can set up your endpoints by defining the configure routes method in the controller, in addition to using the default basic or full CRUD methods. Use the handle route method to set up a basic HTTP response system. This handles errors based on the error type and returns the appropriate response code. The library contains several error definitions to correspond with common response codes, as well as some less common ones. In the route method, you can define the route endpoint, request parameters, and request body as you normally would with Express. Here, however, if you have the auth middleware set up, you should have a user object attached to the request that you can use for authentication. This generally comes from the authorization header of the request. There are also some built-in CRUD methods that you can use or extend. These simply return the response data as usual within the handle route method. This method will then attach the response data to the response and send it. Before you build the app, you need to initialize Firebase, like this. Turbo API returns an Express.js app, so if you want to test locally or from any location, if you intend for your API to be accessible from anywhere, you can use cores just like you would with a vanilla Express.js app. Use the build app method to build the Express app and set it up as a route on your Firebase Functions app using onRequest. Use Firebase deploy to deploy the functions to Firebase. This will serve as your API. You can actually host multiple APIs in one Firebase Functions app this way. Once the app is deployed, you should be able to interact with your database. Create one if you don't have one already. Make sure your database rules will allow your Functions app to interact with it. You can also seed your database with data manually. You can also create data without a login if you have the no metadata and isPublicPost options both set to true in your CRUD methods. Otherwise, you'll need to log in via Firebase and use the access token property on the user object to make an authorization bearer token header. Once you have some data, make sure you set the isActive property to true. You should be able to retrieve it with a GET request using something like Postman.